Hi, welcome back to the next episode of INST 314 Statistics for Information Science. I'm very excited to bring you this next lecture topic on variables and data sets because it really builds the foundation that we're going to be putting everything else onto. Variables give us the way to classify our information that we're going to be using for future analyses, and data sets give us a way to kind of store this information in a way that we can transport it, reshape it, move it, and do a lot of work with our different variables. So with that, let's get started. In this particular video, we're going to be focusing solely on establishing a base statistical terminology for variables and their data sets. So let's go ahead and get started. New pieces of information that we need to kind of just store, that jargon that we're going to be building up, is a data point versus a data set. Data points are just single pieces of information, like the number 1, or apple, blue, dog, 23, 314. All of these, it could also be a sentence. Oatmeal is my favorite breakfast, or something in that case. A data set, however, is a collection of multiple data points. We string them together. Well, I usually use the term string. We're going to come back to that one. But we group data points together so we can have multiples of them, like the numbers 1, 2, 1, 1, 2, 3. That, when we have a single common group of data points, is what we call a variable, or a vector. Data sets occur when we have multiple variables coming together, although technically a single vector could be its own data set. Not common, but it can happen. So usually when we refer to a data set, we're going to be referring to multiple variables or multiple vectors that have been brought together, like a vector of numbers, a vector of letters, and a vector of colors, or perhaps a vector of sentences. If you think about a Twitter data collection, all of the different tweets could be one particular vector, with other vectors being the profile of the person who tweeted, the time they tweeted, the geolocation, and so on. Another thing we need to consider when we're talking about our data points are the units of analysis. These are the actual base level of those that we're taking a look at. They're also called units of observation. If we're thinking about the spreadsheet sort of view with rows and columns, this would be the common denominator of what is in the different rows. So if we're looking at county level data, each row would be the particular counties across whatever geography we're looking at. If we're looking at the University of Maryland individuals in this room, the common denominator would be the UMD students. Perhaps we'd be looking at some medical health data, and so at-risk patients might be the units of observation. Let's break this down into then the parts of a variable. So we said you have a variable and it's groups of different data points. So the process of making it a variable is when we take these different data points and we put them into these little buckets of mutually exclusive and exhaustive categories. What does that mean? Mutually exclusive means you can only be in one particular bucket. The number 1 is only the number 1. The number 1 is not also the number 2 or the number 3. It's just the number 1. Or if we were talking about primary colors with yellow, red, and blue, then we are talking about yellow, red, or blue. Blue is not yellow, blue is not red. Exhaustive means that we have completed as much as we can for the different types of categories. So if we said primary colors, all we have to say is yellow, red, and blue. If I said numbers 1 to 10, then number 11 doesn't have to be part of that because it's not a number 1 to 10. So the different parts of a variable consists of the name. What is it? In the case of the example on the screen, we have an interest in recycling. This variable is measuring someone's interest in recycling. That variable has some sort of definition. If this is a survey, it would be what's the formal question that is asked for that particular variable, such as how much interest do you have in recycling? A great deal, some, hardly, or none. The different categories are the different response options, and you have to have at least 2 because, as we're about to see, we have to have some room for variation. So in this case, we have the categorical response options of great deal, some, hardly, any, and none. Then the procedure for sorting. This is how we're coding it out. We could just use this as character information. We could code these as individual numbers. In the example on the screen, great deal could also correspond to a code number of 1. Some could correspond to a code value of 2. Somebody who says they don't know could correspond to a code value of 8. Keep in mind, don't know is not one of the official categories that was given. What you often find, especially in response survey type data, is that somebody might give you what we call a non-answer. This is when they refuse to answer, they don't know, or it's just not applicable to those individuals. And so the person recording the data doesn't want to just completely drop it, so they enter in one of these non-response values. And when we're working with the GSS, all of the non-response value types are automatically coded out as missing, and so they won't be included as part of your analysis. But you may come across certain data sets that still have and maintain the non-responses that you might be able to do different things with. Keep in mind, when we're running these analyses, sometimes non-responses could be what exactly it is that we're interested in. Like, what is it that causes somebody not to respond to a survey? I just mentioned before that variables vary. So in order to be able to take these ideas and talk about them with the different groups and the samples and whatnot, the game that we're trying to play here is explain the variation. That's ultimately what we're trying to do, is figure out why something happens in the way it does. And the more we can rely on explaining why these things happen, the more we're able to explain this variation. So there's different variables that we can have as these characteristics. We're going to look at an example county data set, and we're going to look at things like name of the county, state it's in, POP 2000, and let's go ahead and take a look at some of these characteristics here. So this is a snapshot. It actually comes from your textbook in page 11, and looking at the 7 rows of the county data set, we can see it's in this sort of spreadsheet view. The numbering on the farthest most left, that is just an identifier to let us know what row it is we're looking at numerically. The first column that has a variable name is name, where it has the name of the county. The next column is the variable for state, and we see it goes from AL for Alabama all the way down to WY for Wyoming. The next variable column is POP 2000. This would be a numerical count of the population in the year 2000, followed by the next variable of POP 2010, which is the population in the year 2010. We could do different things like contrast POP 2010 minus POP 2000 to figure out what would be the increase or decrease in the population between them. The next variables along the way, Fed spend, poverty, home ownership, multi-unit, etc., are different types of variables that are part of this county level data set. Data sets can take different formats, wide or long. We just saw a version before with a county data set. That would be wide, where each county appears once in the rows and then has a single column for every variable, and those variables could be somewhat distinct. So, for example, A1 might have been POP 2000, A2 might have been POP 2010. And we could possibly look at this then in the long form, where we could have a county appear on more than one row. So we could have the first county on rows 1, 2, and 3. ID2 might be population, and so A1 might be the population in 2000, A2s could be 2010, A3s might be 2020. So every time we see ID number 1, that would be the first county, ID number 2 would be the second county, ID number 3 would be the third county, and we would just see the populations for 2010s, 2000s, 2020s, all going down. You're going to learn how to reshape data sets between wide and long when you get to your data manipulation course, but that's not something we're going to cover in this class. Another very important thing for data sets are codebooks. Sometimes this is just as basic as having a list of the variables and their descriptions, like what we see here on the screen, where we see name is the county name, state is the state where the county resides, including the District of Columbia, POP 2000 is population 2000, and so on. But good codebooks go a little bit farther. Good codebooks may include things like toplines. Toplines show sort of some introductory summary statistics, usually frequencies. In the case of what we see on the screen here, this is from the General Social Survey, and we see response options to this particular variable across different years that the General Social Survey was asked. But also what's part of a good codebook, and in this case the top line, is it also gives us the name of the variable, in this case WRK home for work home. The description would be for the question, how often do you work at home as part of your job? The categories are on the farthest left where it says the different types like never, a few times a year, about once a month. And then we get down towards the bottom where it says the non-answer options, don't know, no answer, not applicable. The punch values on the side, these would be numerical coding that would be used for people when they were taking the data from the survey and putting it into a sort of spreadsheet mode. And so these are the good sorts of things you find in a codebook. Even better codebooks will go farther and talk about things like the methodology of how the data was collected, the sampling that was used, what they did with missing values, when it was collected, who collected it, and things like that. So when we go ahead and talk a little bit more about data and the data sets, we have to think about the types of data that are inside data sets. And from that, we have two types. We have the kind that can be measured and the kind that can't be measured. The kinds that can be measured are what we call numerical, the things that we can count, and things that are not measurable, or at least not in a quantitative way, is categorical data. This data tends to be more qualitative in nature. So from these, we can break them down a little bit farther. Categorical, or the qualitative kinds, consists of nominal and ordinal, where the quantitative consists of numeric, which are interval and ratio. And of those, in the ratio, we have discrete and continuous. Nominal variables contain anything that nominal variables contain groups of unordered things that you just can't put them into any sort of natural ranking. Whereas ordinals, these are categories that do have a natural ranking. Think of the O in ordinal to correspond with order, and the N in nominal to correspond with the names of things that can't be ordered. And numerics, these are our quantitatives. These are the numbers, the things we can do the crunchy pluses and minuses on. Intervals are things that have equal distances between them. But ratios are intervals with also true zeros, and the distances between those intervals are ratio values. So think of the O in ratio sort of like the zero, the shape of the zero. And inside ratio, we have two different groups. We have discretes and continuous. Discretes are your integers, 1, 2, 3, etc. Continuous, these are the infinite values. So they can have decimal points and go different places, negative, positive, 1.2, 23.9, and so on. So let's look at a few examples of these. Nominal variables could consist of things like hair type. Somebody who's bald, straight, curly, wavy hair, none of these are better or worse than another. They simply are. Contrast that to religion, where we have groups like Christians, Muslims, Jews, Hindus. Again, different types of religions, but one is neither better or worse, higher or lower. They just simply are. Where ordinals, remember, these are the ones that can be ordered. So next time you go to your favorite greasy food joint and you order yourself a size of fries, they might ask you if you want small, medium, large, or supersized. And so the small is definitely smaller than large, medium is smaller than large, and supersize is larger than large. So there is a natural ranking. Grades you might get in this class, A, B, C, D, and F. Somebody who gets a C is not going to be able to say they did better than the person who got an A or a B. And F is definitely smaller than D, C, B, and A. When we're looking at the numerics, some examples we might be able to say are, of the intervals, temperature in Celsius. So 10 degrees Celsius is colder than 30 degrees, and minus 10 degrees Celsius is colder than 10 degrees Celsius. But 0 degrees Celsius is not no temperature, it's just zero. It's when things start to freeze on the Celsius scale. LSAT scores are a similar system, where LSAT scores, they don't actually start at 0. They start at much higher, so it doesn't even have a 0 value. And somebody who scores 500 is better than a score of a 200, and so on. Discrete ratios, these are the integer counts, so we can think of the number of people in the class. There's no 1.5 people. We say that on average, there might be 2.2 children families. We might say that on average there are 2.2 children in a family in the US, but 0.2 is not an actual child. There's either 2 or 3, what averages to a decimal. So the discretes say there would be 2 or 3. The number of YouTube views might kind of go on the same way. Something might have 5,000 views or 5 million views. 0 views mean that it hasn't been viewed at all. Compare that to continuous ratios. How much syrup do you have in a waffle? We could take a little pitcher and a waffle. We can begin to pour syrup onto the waffle, and when it exactly fills up, we can stop, and we can measure it to an extremely small value, as many decimal points as whatever measuring tool we're using will give us. Think of it also as the size of the Death Star's exhaust port. That's my little Star Wars reference, so when they're flying across the Death Star and they're shooting their little torpedoes down into it, that size of the exhaust port has a continuous value to it. Maybe it's 2 meters, maybe it's 2.2 meters, and we can go from there. So wait a minute. Some things could be debated, and I'm sure there always is in every class. Usually somebody will come up and say, well, and there is this one variable, and I can't quite figure out what it is. Color is a common one that's often brought up. Is color nominal or is it ordinal? Well, to that point, we have to think, are we treating it as a spectrum or not? If we just take a group of colors and we say yellow, red, and blue, and also let's put in there green, purple, and orange, then we might be able to arrange them into a spot where there's a color gradation. In that case, yes, I would let you go ahead and say it's ordinal. But if you're also popping in colors like black, silver, white, and brown, then that color spectrum is not as clear, and they tend to fit more into unordered categories, or nominal. So also think about something like age. Is age going to be counted year by year, or are they in groups of ages? 18 to 24, 25 to 30, 31 to 40, and so on. If ages are counted by the year individually, then we say it's numerical. If it's grouped, then we go ahead and say it's categorical. And that categorical would be ordinal. There is an ordering to them, but they're not individual numbered groups, like saying someone's 21 or 32. Same thing as saying as if it's age or continuous. By that point, we have to ask ourselves, how finite are you counting? If we're looking at a baby, if you count discretely, would be 0 or 1. But a baby can't quite be 0. It wouldn't exist at 0. So we would say it's 6 months or 0.5 years. So in that case, it would be continuous. So just consider, how is it being counted? How is it being grouped? And so on. For the most part in this class, I don't really want to split hairs on how the variables are going to be measured. We could make a case depending on how you're working with it, but most of the tests will conform fairly well with just some basic categorization, if it's nominal, ordinal, interval, or ratio. But if we really wanted to take this argument, we'll bring in some of the philosophers and see what they say. Looking at some of the R data types, we've got things like double and numeric, integer, logical, character, and factor. These are not the same types as what we just saw with nominal, ordinal, interval, ratio. That's because R doesn't think of variables like we think of them statistically. It sees them as data points that it can process. So doubles and numerics, these are the numbers with decimal values, whereas integers are the ones without decimals. Those are that's like comparing the continuous and the discrete. The logicals, those are trues and false, also known as booleans. Character is anything that can be put inside of a string, or inside quotes, if you will. So the number 1 could be an integer. It could be numeric, it is 1.0. But if we put 1 inside quotes, 1 is no longer the number 1, it is the string 1. And that brings us to factor. Factor is sort of the odd duck out. Those are integers that are being treated as categories. So they're still numbers, you can still process them sort of, but because they're categories, they're treated more like characters. And oftentimes we see factors with a text label that has string characters that mask the integers. So you might have the values 1, 2, and 3 as a factor, and it might have the labels on it, small, medium, and large. So when you run it in R, you're going to see small, medium, and large, but underneath those labels are the numbers 1, 2, and 3. Factors can be ordered or unordered, depending on how it's been set up in the code. Just keep in mind and be careful that sometimes when you run something in R, you might be looking at a series of numbers, but those numbers might actually be a factor. So lastly, we're going to go ahead and just take a look at an example of a data set as it might appear in R. This is the structure command. We're going to be coming back to it, str. And in parentheses is the name of the data set as it appears in R. So we're looking at airbag data. It tells us it's a data frame, which we'll get to in another lecture. It has 26,217 observations, so that's the number of rows it has, and 16 variables, so those are the number of columns it has. The $sign indicates that's the name of the variable inside this airbag. So we have the variable x, the variable dvcat, the variable weight, and so on. And x is an integer with value numbers 1, 2, 3, 4, and so on. dvcat is a factor variable that has 5 different text levels, such as 1 to 9 kilometers per hour, 10 to 24 kilometers per hour, and so on. Weight is a number variable, so it's numeric. It can have decimals like 25.1, 32.4, 495.4, and so on. And looking down the line, we can see that this data set comprises integers, factors, and numeric variables. Other ones might contain booleans or characters, but not in this particular data set. So this goes ahead and concludes variables and data sets, and I'll see you in the next lecture.